Okay. Yeah. So welcome to the next session in the Databricks training. So we will discuss the Azure Event Hubs today and streaming from Event Hub connecting to Databricks. So basically, as I said, right, Event Hubs is a kind of used as a event-driven architecture model where you can publish and subscribe messages from these event hubs. So it has native built-in support for Apache Kafka. Kafka is also again event-driven architecture tool, which you call pub sub service. You publish and subscribe. So what is a publish? What is subscribe? What is hub and spoke model? Is what we will talk about. But if you look at the overall architecture thing, is this is more about the Azure, right? So you can also see here Azure Databricks, correct? Um, any of the streaming data, we talked about log files, uh, weather data, business application, sentiment data, like streaming from either Twitter, that is X, or Facebook, any social media, or logs files, or streaming data, weather data, event series, all of this they can be streamed through Kafka to event hubs or directly to event hubs, which is a publish subscribe model. Within the event hubs, all of these events, each event is stored and then can be consumed by any of these tools. So Azure Stream Analytics is a tool which you can use to do the real-time stream processing from this. So Data Explorer, we will look at today, what it does in the data analytics to test that. You can build microservice functions, apps, services, all of these to consume. You can use Azure Databricks, which is written batch analytics, but you can do stream analytics as well using the Azure Databricks from the event hubs. And then you can also stream to Data Lake storage, or you can write to Delta Lake from Azure Databricks using Parquet Avro format in the Delta Lake. Right? Streaming ETL also. And then these are exploring BI. So you can use Azure SQL, Cosmos DB, or Power BI to explore or look into the data or interact with the data to see the data absent. So basically, what we are trying to do is again the same end-to-end data pipeline. So wherever you talk about data engineering, it is all about building data pipelines. It's all like plug and play, right? So at each stage, you have again source, you have processing, and then you have model and serve, which means you are basically serving the data. Okay. And whenever there is a source, you ingest the data. Data ingestion is like, you're writing the data into the platform. So everywhere, data engineering, this is the standard platform, standard pipeline. You have data sources, you have data ingestion, you have processing, and then serving. Okay. Source, ingest, process, and serve. These are the four stages. Sometimes, ingest is basically represented within the processing layer, but you can also separate that because we also have three layers here, right? You have like medallion architecture, bronze, silver, and gold. You can model your data into three layers, right? So raw layer, whatever you ingest from here, it will go into raw. Then you have the processing, right? The processing will take care of from raw to silver and silver to gold. And from gold is what you will serve the data, the model and serve data, right? So this is basically the same architecture. Wherever you talk about sources, ingest, process, serve. Now, at each of this stage, the tools will change, right? So whatever, there are multiple various tools. You can choose whatever tool best serves your purpose. Okay. So sources, some based on your use case, based on your company, not all of the sources may be available, right? So let's say you are having a um, uh, manufacturing, okay, organization. They don't need weather data, maybe. I'm just assuming they don't need, but maybe they don't need streaming weather data on a regular basis. Okay. maybe they don't need customer sentiment data yet because they are not directly selling to the customer. They are not retail sales, so they don't care about the sentiment data. Media data they don't need, maybe, right? So they might have business applications that is sending their data for analysis. Some may have logs files, some may have streaming data. So based on whatever event sources you have, you will integrate or ingest data from these sources. And again, it's not mandatory that you will only have one ingestion source here. Okay, say for example, I have streaming data. I might use Event Hub to stream the data into Azure Databricks. Then maybe I have some batch data coming from business applications. I don't need to go to Event Hub. So I can directly pull using Databricks batch job, which can directly read from, maybe from here, it is going to S3. So I can have an S3 bucket also here as an ingestion source. Here, source. So business applications are writing to S3. And then we looked at writing data from S3 into Databricks. Either it is batch or it is a streaming. So you read from those S3 sources and then process to Azure Databricks. So again, so then we explored ingestion can be, you can have event hubs, you can have Kafka, and again, you can have Kafka on event hubs. You can have Amazon S3, you can have ADLS, you can have databases directly reading, whatever it is, right? So different tools. Processing, we are talking about Azure Databricks predominantly here, but again, you can use Azure Stream Analytics also to process. You can use Apache Flink, Apache Strong. There are so many tools that can do the same stream processing, that can do batch processing, right? You can also have a straight Python script to read and process. That is also possible if you don't need Databricks or PySpark or whatever parallel processing. So whatever it is, again, at the processing layer, you can have different tools. Serving layer, your organization may have only Power BI to read, or they can read using Cosmos DB, or they can have Tableau, or they have a data science algorithm that is reading data science application or model that is reading from this layer. So there could be multiple different tools here that need data from the serving layer. That a serving layer that needs data from your process. That is your goal layer. Okay. So the summary of it is always you will have these 3 or 4 layers, but the tools in each layer can be different that you use. The source can be different. For ingestion, you can use different tools. For processing, you can use different tools. And for serving, you can use different tools based on what is your best, what is your organization has. Right? So let's see. So what is the event hubs? Azure Event Hub. What does it say, right? So event hub in the sense, it's like a hub and spoke model. So at the center, you have a hub where the data will reside. Then you have producers and consumers. Producers also, we called earlier, it is called publisher. Okay. And consumer. Okay. So you have publish, and subscribe. Earlier it was like pub sub models, they used to call publish and subscribe model. Some applications will publish, some applications will subscribe to that. Right? So whoever is subscribing, the data will be broadcasted to them. Whoever is publishing, they will publish the data into the hub. Okay, so input and output. So there is a hub center. So let's think of it as a water storage, a water tank. So there are there are inlets, that water is pumped into the tank, and there are outlets where the water is flowing out to different sources. And in the tank, the water will be stored for certain period of time, some kind of thing. So same nomenclature from the pub sub. Now it's called, producer and consumer. It's very straightforward, as the name suggests. Producers produce the events. Okay. Again, what is an event? Event is just a message. And what is the message? It's just a data. Okay. It's maybe one row of data, one entity of data, one object data. So whatever it is, one unit of data is what is your event. Let's say on the upstream, some application you have, there is a new customer walked in, and then you registered the customer on any store. There's a new customer, you registered the customer. That is an event. There is a customer event happened, and you want to publish that event to your hub. Okay. So there is a new customer. So what does the event have? Customer data, right? So customer data can be his customer personal data, it can be address, it can be phone, whatever it is. So it can be all be one event. Or you may want to split and say there is a customer event, there is an address event, there is a communications channel event like phone number, email events, whatever it is, that is up to the design. So let's say it's a customer is an event. Now they have published the event to hub, an event hub. Okay. Are you guys still with me, or am I talking to myself?
Yes,
Yes.
you stopped sharing.
You
Yes.
guys are following, right?
Yeah.
Yes.
Yes.
Okay.
Yes.
So please stop me if you have questions, and let me know. Okay. So an event is published. There
Arun,
can
are
be
you sharing something?
what? I'm not sharing. I'm sharing.
No.
Yeah. Says your screen sharing.
So
Nobody can see this.
No, it's visible actually.
I can
we
see.
can see.
Yeah, I can see.
Yeah, I think I'm sure it's only you're not able to see.
I can see you on the screen. I don't see anything else.
No, I think you have to see maximize.
Hmm.
I think you have pinned him. Just unpin.
Yeah. And yeah.
Let me rejoin or do something.
Yeah. Okay. So yeah. So basically, so it's the event producer, right? So whatever you are like, you're producing an event, that event is published to the hub. Okay. So it can be the protocols, HTTPS, AMQP, or through Kafka, whatever it is. So you will publish to the hubs. So the hub will have partitions. Okay. 1, 2, 3 partitions basically, and a topic. So basically what we talked about, right? So let's say the event happened, the customer registered, and on the hub, we have multiple different topics. Okay. So let's say customer is one topic, address is one topic, phone is one topic, and say his email is one topic. 4 topics. Okay. So topic is just kind of a category, for example. So when customer is registered, his data is split into 4 categories because I have 4 different topics. Now, each topic can have partitions. So partitions is just again, organizing into different racks. Okay. So same customer, let's say if I'm getting 1,000 customers, okay, topic will be customer. And again, that topic can have multiple partitions, 4 partitions, 5 partitions. So these 1,000 customers will be divided into partitions, just to write into different racks. They will be distributed into different racks, but the label will still be customer. Okay. Customer has 4 partitions. So which means that customers will be distributed into 4 racks when they are stored here. Now, why do we need 4 racks? That I will come later. It can be 4, it can be 3, it can be 2, or you can just have only 1 rack. I don't need, hey, I'm getting very few customers. Customers can be just 1 rack. I don't need multiple racks to distribute the customer. So whatever it is, so let's say I have a Kafka, I have a topic, event hub 3. I have a topic, I have multiple partitions inside it. So these are multiple event hubs that you can create within the namespace. So I'm just dealing with one event hub. So there is one topic and multiple partitions. Now there will be another topic called address, and address may have two partitions. Okay, phone may have one partition, kind of. Now that is all published. They are all saved in the event hub. Now, as you know, in the logs, you can call logs or you can call event hubs, whatever. So there will be some similarity when we talk about Kafka, because Kafka and event hubs are similar. Even you can see through Kafka also, it can, and it's natively built on Kafka support. So Kafka can directly interact with event hubs. We will talk about it, Kafka, separately. Now, event hub 1, 2, 3. Let's focus on one event hub that we created. It has a topic, event hub or Kafka topic, and multiple partitions you can do. Then we have producer that is sent, the data is stored here. Now, who will read it? There will be consumer. Okay. So let's say I have a CRM. Okay. And then I have a marketing, and there are marketing department. I have a telemarketing department and then customer marketing department. So telemarketing department only needs customer details and phone number. Okay. Social media marketing needs customer details and email. And mail marketing campaigns by mail needs customer's physical address and customer name. So three different channels, three different departments that do marketing have different needs, correct? You guys following me?
Yes.
Anshu,
Yes,
can you
all
see the
clear.
screen?
Yes, sir.
Okay. So think about it. The customer data has come in. It has 4 different categories. So we split into 4 topics. Customer, which is his name, first name, last name. That's all, that information. His address, physical address, his phone number and email, 4 topics. Now on the consumer side, within my company, I have 3 different departments. One are doing only email marketing. One is doing telemarketing. One is doing through postal mails. Okay. And they don't need all the data. All 3 of them need customer data, right? Name, first name, last name, they all need. Physical mail marketing, they need physical address, house number, street, zip code, PIN, and everything. Telemarketing guys need only the phone. And email, social marketing need only the email address and the customer information. So these 3 departments are considered as three consumers. So they will subscribe to different topics on this channel. Okay. The mail marketing will subscribe to customer topic and address topic. The telemarketing will subscribe to customer and phone number topic. The social marketing will subscribe to only customer and email. Customer is common. All of them need customer information, but rest of it, they need each respective to that. So then let's say CG1 will read from topic 1 and topic 2, customer and address. CG2 will read from topic 1 and topic 3, and CG3 will read from topic 1 and topic 4. So they can subscribe to whatever information they need and they can read it. So that's how the publish subscribe model will work. Publisher will publish to topic wherever they want to that topic, and subscribers can connect to the hub and then read whatever they need, topic, whatever they have registered. They will check, is there any new data, just like post boxes, is there new data that's coming in to my topic? So from what I have read last, the new records, I will read those records and process. Okay, so that's how the pub sub model works. Now, why do we need multiple partitions? Is to improve the parallelism. Okay, normally if the data comes in sequence, as and when it arrives, it will come in sequence. We will revisit again when we talk about Kafka. customer 1, customer 2, 3, 4, they come in sequence. Address 1, 2, 3, 4, they come in sequence. Okay, first in, first out kind of a thing. Now, when the consumer connects to customer topic, it can read from beginning 1, 2, 3. So it will be sequential. Suppose there are a million customers, trading, for example. There are like a million people who's doing trading, and you are reading from who is doing the trading. So you cannot sequentially read one by one. So you have to read in parallel. So to read in parallel, you create a consumer group, and within the group, you can have multiple consumers. It's like, cloning your consumer. Say instead of doing one, say for robot, right? So instead of one robot, you clone 10 robots to go and read parallel, to do the job parallel. So now, instead of reading one customer, 10 consumers read 10 customers in parallel from the topic. But they cannot read from the same topic. So that's why you have partitions. So the parallelism will be defined by number of partitions. Remember, I told you customers are all put, let's say I have created 4 partitions. So four racks, all 4 racks will be labeled, hey, this rack contains customer data. But again, the same customer data is in 4 racks. So 4 racks, like customers are coming in, they'll be distributed, put into all 4 racks on a round robin basis. Now, consumers are going in, picking up from the racks. Since there are 4 racks or 4 partitions, the maximum parallelism can be 4 consumers. So I can put 4 people to go and read to go and fetch the data from 4 racks, right? At the same time, 4 people can go and fetch. You cannot put 5 people because 4 consumers can read from 4 partitions, and 1 consumer will be idle because he doesn't have a partition to read from. Only 1 consumer can read from 1 partition. Okay, so that's how it is designed for parallelism. Now, if you have huge number of customers, like I said, 1 million, then to increase the processing, to increase the parallelism, you have to increase the number of partitions. That's when you can do parallel processing, read parallelly and process faster. Okay, so I know all of these are too many terms, but try to understand the logic. Okay, all that is happening here is data is coming in, somebody is pushing data, and we are organizing the data into different racks. First by topic, and within the topic, let's say all the first row is customer, second row is address, like that we are labeling. So those are called topics. Now within the topic, we will put into multiple racks. Okay, so all racks are again same because label is customer, but we have multiple racks and we keep putting the data into all the racks equally so that one rack doesn't fill up, right? So in the round robin, so we distribute so that when consumers come in, they can read from all the racks parallelly so that processing can happen faster. So that's what is happening. So producers will produce the events and put it in the hub. Consumers will read from the hub and then process. So this consumer is where your Databricks that you're processing, right? Batch processing or a stream, read stream from the Databricks will be your consumer. So you can read from the consumer from the event hubs, process it, and then everything is same. Your raw layer, silver layer, and gold layer will continue from here. So this part is all event hub where it stores. Now there should be somebody who is producing the events and publishing to event hub. Okay, so that is all the architecture. Now the producer and consumer we will do when we come to the Kafka. So event hubs has something called we looked at here, data explorer, right? So the data explorer gives you a kind of a facility to have a publisher to publish from here to any of the event hub. So this is what we have talked about. What are the components of Event Hubs? Is producer application. These applications can ingest data into an Event Hub by using Event Hub SDK or any Kafka producer client. So any Kafka producer can write to Event Hub or any Event Hub SDKs you can use to write. This is important. Ingest data to an Event Hub. This is your producer who is publishing the data into Event Hub. Namespace is just like a container which will have one or more Event Hubs or Kafka topics. Okay, so this is basically your Event Hub namespace. Within that, you can have multiple Event Hubs or Kafka topic. Event Hub or Kafka topic is called, it's organize events into an Event Hub or Kafka topic. It's an append-only distributed log which can comprise one or more partitions. Okay, it can organize events in append-only distributed log. Okay, so which means, so this is a log which is actually distributed on multiple machines that I don't worry about. In an append-only mode, first event comes in, the next event will come here. You can't go and update an event once you publish. Okay, so you publish first in, then the next one comes behind it. They start queuing up. Whatever you publish to the topic, they start queuing up in the same topic or Event Hub. Of course, within that, it can be multiple partitions. So again, right? So you have 4 racks. You don't know which rack it will go to, but it will still be in the same topic, which can comprise one or more partitions. Partitions are used to scale an Event Hub. This is what we read, right? They are like lanes in a freeway. Exactly. In the freeway, you have 1, 2, 3, 4 lanes, right? If you have just one lane, even if it's a freeway, everybody needs to go in the same lane. If you have 4 lanes, then 4 cars can go, right? 4 traffic can flow in 4 lanes. So it will flow much faster. If you need more streaming throughput, you can add more partitions. All you have to do, say I'm getting 1,000 customers now. So tomorrow I'm saying, hey, there might be 10,000 customers that are coming in. So what I will do, I will increase number of partitions and then I will increase number of consumers. So that it's like adding 2 more lanes to the freeway. Right? Are you getting the concept?
Yeah, yes.
Yes.
Okay, Nabi said yes. I will ask.
When we send when we send an event, right? Which event hub? There are 3 event hubs, right? In your example,
Yeah.
like suppose if we send if producer sends
Mhm.
customer data,
Mhm.
how do we know which event hub it goes to? Like, do we handle programmatically?
Good question. Good question. Yeah. So when you publish an event, there are 2 things you should,
Mhm.
or rather, I think 3 things you should send in an event. The first thing is the address of the hub, the server where your server is, where it should go and sit. The second is your message. What is the message you are sending? And the third is your topic or event hub, to which event hub or to which topic you are publishing. So obviously, you will send the topic name and the message and the address. So it will go to this address, that topic, and write that message. So yes, it's a good question. You should actually send in the topic when you send the producer. You don't need to send the partition, but you need to send the topic, to which topic you are publishing. Similarly, consumer also,
Yes, similar consumer also. Yeah,
yeah,
similar
same thing.
consumer also need to
They should
mention.
get the
Yeah.
address and they should know which topic they are subscribing to. Okay.
Okay.
So they can only read from that topic. They cannot read from other topics. They cannot read, from all topics. So they can only read from a topic to which they are registered.
Okay.
Okay. Any other questions? So that is the partitions we talked about, increasing the throughput. Consumer applications can consume data by seeking through the event log and maintaining consumer offset. So what is consumer offset? We will talk about. Consumer offset is, let's say I told you, right, there are 1,000 customers. I have read 400 customers. So there is an offset that is set for that consumer, that this consumer has read from this topic up to this customer. So next time when it comes to read, it will start reading from 401. It does not always. So it's like a watermark. You should know, right? So when you're reading a book, you read 20 pages, you put some bookmark there and close it. So next time when you open it, you know from where you have to read. The same bookmark is your watermark, or you call it like offset. For that topic, for that consumer, it will remember what is the consumer application will have the offset. So from there, it will start reading. Consumers can be a Kafka consumer or Event Hub SDK clients, or you can write consumer and producer in anything. You can write in Python, you can write in Java, you can write in Databricks, right? So, but whatever, you have to create a consumer like, a Kafka consumer, or is it a Event Hub consumer, you can create. Consumer group is logical group of consumer instances, reads data from an Event Hub or Kafka topic. It enables multiple consumers to read the same streaming data in an Event Hub independently at their own pace and with their own offsets. Okay, so basically what it's saying is partitions. You start reading from the consumer. Okay, give me 1 second. I just want to make sure. To do a representation of what we are doing with the hub and spoke model. Okay. Okay. So let's recreate what we talked about the events, event hub, right? Let me see here. Now I have a publisher. Okay. So what is it publishing? Data. We said customer data, which is name and other thing. Address. What else?
Email.
Phone number.
Phone
Email.
number.
Phone.
Email.
Right. So what are we calling this?
Producer.
We are calling topics.
Topics here.
Okay. So publisher is producer, publisher or producer, whatever. So he is publishing events. Publishing events, right? Now, what are the events? One event. Now, let's say these are 4 topics. Now, it's a customer topic, address, phone, email, and within the customer topic, so I have a on the hub, right? So let's say this is a hub. So I will have okay, these are the topics. So on the hub, in customer topic, I have 4 partitions. Okay, then I will do partition. Or say 3 partitions. So address, I have partition 1, partition 2, and Phone, I have partition 1. And email also, let's say I have only one partition. Okay. So these are, each topic is a event hub, correct? And in that, say I have 3 partitions. So this one, and address has 2 partitions. Within this, so this partition now, let's say I have consumer group. Consumer group, I will have customer CG is customer consumer group. Customer consumer group. So in this, I can have consumer. So now what is our rule? I have 3 partitions. So consumer can read from one partition. So let's say I have one consumer. So I'm just creating consumers here, 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 and here. How many consumers I have? One for each topic. Okay, for customer, I have one consumer. For address, I have one consumer. For phone, I have one. Email, I have one. Now in this partition 1, customer, so there is now data keeps coming in. Okay, so there is one customer written here because I have multiple partitions. I have here, 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 here. Okay, now this 2, 3, 4, 1, 1, 2. Okay. Now this consumer can read from one partition. So let's say it's reading from this partition. So it can read 1 first, then it can read 4. Now there are no more in this, so it can read from this partition. Now it can read 2, it can read 5. Then it reads 3, then it reads 6, right? So what is happening here? It is reading in sequence or sequentially, correct? Here also
Yeah,
it is
yes, sir.
sequential. So 1, 2. Here also it is sequential since we have 1, 1 consume. Now we want to increase the processing power, the speed of consuming data, processing data. So I want to have parallelism, right? So I have an option here because these partitions nobody is reading. There is only one consumer, so it can only read one partition. So what I will do in this consumer group, I will create 2 more consumers. Okay. Consumer 2, consumer 1, and consumer 3. So these are all very simple terms, it's basic common sense. Data is coming sequentially, you are reading sequentially. So it takes in sequence from 1 to 100, just like you are going to a milk booth, you're standing in line, you're taking one packet coming out, so everybody goes in queue and takes out. Okay, but let's say it's like a railway reservation counter. So you have 4 counters, right? So then 4 people can take tickets at the same time if you stand in 4 different queues. It's just like free lane. What if the 2 counters are closed, right? Or there are 3 counters, but you're closing that. Nobody is allowed to go into that lanes. So 2 lanes are closed. Then like everybody is going in 1 lane only, even if there is availability for 3 lanes. So then again, it will get clogged. So to increase the parallelism, you have to have 3 lanes. And then you have to allow traffic in 3 lanes. That's why we are saying we'll do consumer 1, 2, 3. Now what happens? All of them will go in parallel. So when this is reading 1, this will read 2, and this will read 3. Okay. Now this will read 5, this will read 6. So same thing if you put consumer, 2 consumers in this group, then it will read 1, it will read 2, it will read 3, it will read 4. So the most important question they'll ask is, how do you increase the throughput? It's called throughput. So when you are doing a streaming application, how do you make sure to increase the throughput? So there are 3 or 4 steps that you should do. The first thing is you should say, we should increase the parallelism by adding more partitions to the topic and more consumers within the consumer group. So then the parallelism will increase. If we have 100 partitions, we can put 100 consumers. So at any given time, it can read 100 events at a time to process. Okay. So that's how you increase the parallelism and throughput. The other thing is you have to check whether the data is being choked at the ingestion, because the point is, let's say you have 4 partitions, 4 consumers, but 100 customers coming in per second. But you are only processing 4 customers per second, even in parallel, which means your input is more than your output, the processing power. So what you have to do, it gets choked. More and more data gets logged in, and it gets choked, and ultimately it will break. Right? So you have to make sure that your processing speed is matching with the input, or you have to throttle the input. You have to reduce the speed of the input, or increase the parallelism and processing power, so that you process it as per the speed at which the data is coming in. Okay. So did you get all of this?
So Harun, one question. So at some point, like, we cannot keep on partitioning. There should be some limit over there. What will that limit be? Like, if my processing limit is just, for example, say 100 partition. So does that mean that I can just take a number of consumers and number of producers, right?
Yeah. So your partition is not limited. You can keep adding partitions, right? So you can add any. So this is distributed. So these partitions are distributed on the machines. Okay. One log. So again, you can call it logs. So one partition should fit on one machine. So you can have multiple machines. So your topic is distributed across multiple machines. So if you want 1,000 partitions, you can have 1,000 partitions. You just need to add more machines if your partition cannot fit into one machine. So that's how you can increase your scale up your processing, your machines, so that you can have partitions, more partitions. Or, as I said, you have to reduce the throughput input. So okay, reducing input is not an option, right? Whatever I'm saying, my say Twitter or X, the data is continuously streaming. I cannot stop it. So what will I do? I will have multiple servers having the same topic. Okay, and then you redistribute processing to different machines with the same topic. You subcategorize and make sure some data is flowing there by region wise, or you filter the incoming messages by region, and then you send it to a different event hub. You send it to a different namespace. Right? So like that, you have to redistribute your input so that all of the input doesn't choke onto one topic, one partitions. So it just keep adding parallelly number of machines, and then distributing the load to multiple servers, like load balancer.
Okay, so but it is not necessary that the number of consumer, it will never happen that number of consumer will be equal to number of partitions, right?
Yes.
Anyways, it will be in round robin fashion or any other scheduling
No, you
technique.
can have as many consumers as your partitions. Okay. That is the maximum parallelism. So if you have 4 partitions, your consumer group can have 4 consumers. It can even have 10 consumers, it doesn't matter. But only 4 consumers will be engaged. The other 6 will be sitting idle because there are no partitions to read from. There are 4 partitions and 4 consumers are already reading from them. So what will the other 6 consumers do? They will just be sitting idle. They can't do anything. So that's why the parallelism is limited by number of partitions. You can increase the partitions, then you can increase the consumer. Now, let's say I have 100 partitions, but I have only 50 consumers. That is fine. So the one consumer can read from 2 different partitions. It can read from partition 1, then it can read from partition 2.
So my question is not for 100 events. Maybe the events are more like thousands or maybe millions or 10,000. Like, is it possible to have a million consumers and million partitions?
No, why do you need million partitions? See, partition does not mean number of messages. Partition will
Yeah.
hold messages, right? Partition is again a container. Each partition can have 100,000 messages in that. You don't get a million messages every second or million messages every 1 hour, unless it is something like Twitter or something like Facebook or Instagram. But they will also be processed region wise. You will have same setup, same servers by region, by topic, by content, by date. So whatever it is, they get distributed. The point is each message is not a partition. Partitions are again a division. So each partition may have 100 messages, 1,000 messages. You keep storing the messages in the partitions, and the consumers read from the partitions. There is a retention period. You can set to 7 days, 1 day, 1 hour. So after 1 hour, those messages will be deleted from the partitions.
Okay.
So that is the retention period. And then
Okay.
the same thing
Depending
will be again replicated. So it will have 3 copies of each for redundancy. So if one machine goes down, the same data will be available on the other machine. So there is a replication factor as well.
Okay. Okay.
Got it? So that is the consumer group. So remember, these are the main components that you should remember in Event Hub architecture or in a Kafka also when we talk about Kafka. So we'll reiterate about this. Let's get into a demo first. So to get the basically the Event Hubs, I will show Event Hubs. Okay, I'll give you a couple of these things to read from. Okay. I can go and read what is this. So partition 1, 2, 3, based on the keys, number of partitions, Event Hub, you will have multiple partitions in this, and then all of the messages are in each of these partitions. So namespace, inside that there will be Event Hub. Within the Event Hub, there will be multiple partitions. It's kind of organizing in racks, kind of. To go here, this is Event Hubs. So we looked at this. So how to create event hubs? I will give you this links on the Azure. Once you have the Azure login account, create account. So you can follow this to create a resource group first. And in the resource group, once you have resource group, you go to all services, go to event hubs, create a event hub. In that you get namespace. So once you create a namespace, then you see the event hub within the namespace. Right? Go here and click on. This is the namespace. Inside that you can create an event hub. Okay. And once you create the event hub, you need to get the connection string for that event hub. So why we need that, I will show you. But how to get that, it's connection string to connect to that event hub basically for your consumer, right? So your consumer has to connect to the event hub and read the data, correct? So to read that, you need that key, your host, port, key, and everything. So that is in the event hub's connection string that you need. So these are the two things. I will give you these resources. You can go ahead and try creating these. And then later we will, when we meet again, we can check if we have any issues in creating this. So this is my account, right? So in this, what first we will do is resource group. Okay. So I have created this resource group called RG Databricks demo. Okay. So you can go, there will be here, you can search for create resource and say resource group in the subscription. First, you will create subscription anyway. So under the subscription, the next level is your resource group. Okay. So you can go here, see here, resource group. You can create resource group. I can just say plan. Create. Give it a name. Oh, sorry, give it, you created a subscription, right? At the top level is always your subscription, which is your account. So under that subscription, you select that subscription, and then you just give any name, continue, and then review and create. So that is how you create a resource group. So once you create a resource group, then you can go and create namespace. Okay. Then you say on event hubs. There is a code create. So then it will give you create namespace. It says event hubs, but when you click create, first it will give you namespace. So basically select the resource group that you have created and just give some namespace, name for this. Pricing tier, you can just select standard or basic, whatever. I think basic is good enough. And then continue and review and create. So then once you create namespace, then it will ask for creating the then it will ask to create a event hub within that. What happened to my resources? Okay, so then you can create event hub in your resources. So let me go here. I have created this resource event hub namespace. Okay. And in this, you can go and create, once you create namespace, you can go and create an event hub. So I have that event hub. So I created. So it's the data explorer I was showing you, right? So that will help you to send events. So this you can use as your temporary publisher where you can publish data. Event hub I have created as Databricks demo. This is your topic or event hub. And you can send events from here. So when you send events here, so you can also see partition IDs. So there are two partitions for this event hub. So when you publish data, it can go to any of the partitions. Consumer group, I have given default. So I haven't created. Event position, oldest you want to read first, then first in, first out. It's kind of, and then you can view the events. It's a consumer. You can view. So when it has send events, that's what I told you about, right? So it's just a publisher. Now you can give your custom payload to publish to that topic, or you can use any of the provided data sets to publish. So let's say I'm using Yellow Taxi. Okay, so this will be your assignment to use these weather data or any of these to create the same application processing from Databricks. Now, these are all the properties in that. So this is a JSON format we looked at. And then when you send, you can set up how many events you want to send. I will say send events to a partition using a partition key. So I'm just using partition ID 0, 0 and 1. There are two partitions. So I can send to which partition I want to. Normally it goes round robin if I don't give. Repeat, I just want to send 2 messages and interval 2 seconds. This is in milliseconds, so I give 2000. So it will be 2 seconds, or let me say take 5. As soon as I click send, it will be, the messages will be sent, and then you can go and view the messages in the hub. They'll be sitting there. So I click send, and then I go view events. One, two, three, 4. 4 events are here, total 5 events. So view next events. It's receiving. See now 5 events. I have sent all to partition ID 0, so they landed in the partition, the same partition. Okay. Now I want to read this data and process, right? So I want to consume these messages. So now what I will do, I'll go to my Databricks Community Edition. So let me log in first. So you guys with me until now? Any questions?
Yeah,
No,
no questions. Yeah.
Okay. So basically, if you understand this, then we can do Kafka also will be similar, integrating what is, we'll talk about Kafka and integrating Kafka with the Databricks, right? Or any processing, Kafka as well. Okay. So let me know if you can see my screen. Can see my screen?
Yes.
Yeah, so we are doing this. So forget about streaming sources right now, which are coming into event hubs. we have just used the Data Explorer here to publish into Event Hub. And now we are using Databricks to read from Event Hub into this Delta Lake. Now, there are a couple of things that we need that is specific to Azure data, specific to Event Hubs. That is, the first thing is, remember this, or go watch the video because you will get error when you're trying to do this. When you create a compute, when you say create compute, create. This is normally we create the compute, right? But to connect to Azure Event Hubs, you also need a connector. Basically, just like, in other applications, you have a JDBC connector, ODBC connector, right? To connect to databases. Same thing, you need a connector library to connect to the Azure Event Hubs. So you click on libraries, go to install new and use Maven, search packages, and then use Azure Event. Every time I forget this. 1 second. What is the name? It's Azure Event Hubs connector. Connector. Where is the connector? Point. This is Kafka. So here you search for Azure Events Hub Spark. It is actually very tricky because if you just put like this, it won't show up. Okay, show something else until you put complete Azure Events Hubs. Then you have to Spark, then it will show up. Select COM Microsoft Azure, Azure Event Hub Spark 212. Okay, so why 212 is because your version what you are creating the cluster is Spark 212. Okay, Scala 212. So you have to select this 212, 2322. So remember this. If you don't do this, it will error out. So this thing is additional configuration you need on your libraries to connect to the event hubs. This is the first one. Now the second one is the actually what I showed you earlier, that you need the connect string, right? Connector string. So we will come there. So this is standard functions type. If you want, you can, it's already dropped. You can go ahead and create. We don't have. Connecting, starting. So it didn't do yet. So wait for it. Once that is done, see the 212 is your Scala version. Basically, when you're creating your compute. So the compute has a Spark version and a Scala version. So the 212 is referring to your Scala language version. Spark version is okay. You can, this is 12.2 LTS, this is Spark version, but you have to select that 212 package. Why is it taking this long to create? Okay, so you guys are all following? Is it overwhelming or you are good?
Right on track, Karan.
Yeah, good, Karan.
Okay.
Good.
Yeah. So you have to configure all of this and do a demo next week. Okay, so pay attention, practice. There are 3 more data sets, and then you can also do your own data set as well. We will talk about it. Why this is taking so much? Okay. That is done. I will create this. So this is what I was talking about. Get one. Okay. So I created. So now we want to have the connection string. So this connection string, so this is, you have to take the boilerplate code. This is what you need to connect to the
Event hub.
yes, yeah, event hub. So I'll just put it here. You don't need this.
And how will we get the connection string then?
Yeah. So connection string is basically pointing to your Databricks. So your namespace, what you have created. Remember? So this is the namespace. Access key name, access key, and your actual event hub. This is the namespace and this is the event hub. Entity path equal to this. EHConf is your dictionary. It has 2 keys. One is your connection string. You have to give in this format and pass this connection string here. And event hub name, again, you have to give the same, whatever is the event hub or topic that you are trying to connect to. Now, how do you get this connection string, right? So that's what I was giving you, one of those resource here. Oh. I think I closed it. 1 second, let me show you that. Capabilities. Okay, let me check here. Azure Event hubs connector for Databricks. No, not connector. Connector, we have installed the library. Azure Event Hub connection string example. Connection string. Okay, so this is how you get I'll forward you this as well. I was showing this earlier. So you go to Azure portal, event hub namespace, shared access policies, settings, and then click on your policy, and then you'll have your keys here. How does that look like? Go here. In your namespace. And then you go to settings, shared access policies. And this is my policy that I have created. In this, if you go here, you will have your primary key and secondary key, primary connection string and secondary connection string. So check this primary connection string, copy it, and then you go here. So paste. So see, this one is the same as till this point. Okay. And then you have to add this semicolon, entity path equal to whatever is your event hub that you have created inside the namespace. So what is the event hub? Starbricks-demo, right? So that I have written semicolon entity path equal to Starbricks demo. So that is what you have to add here, your own key and the event hub. So that's how you get the key from there. So these are the two things. First thing is you have to install the library when you are creating the compute. And the second one is you have to get the connection string from event hubs once it is all configured. Okay. So those are the two things. Now you can run this. And then I'm creating a schema based on, the truck type is not defined. What? Now run. I will just copy this. And then okay, so this is the schema. Now Spark dot read stream, just like we did for the file-based streaming. Format, now we are giving event hubs. Okay, so the format is the one that would change. See, last time we looked at format cloud files to read from AWS S3 as a cloud, or we used CSV format, to read the files. And then here we are using format as event hubs. And in the options, we are giving all the configuration. So basically this configuration is this one. So how ehconf, which is your connection string and event hub name. So that is what we are passing here. And then we are saying load and then display this. So if I load, start this. Okay. So it will start running now, and then it will look for any data that is coming in to connect to the event hub and then publish here, read and put it here. Okay, so there is no rows returned, does not have any data yet. So it is looking for the new data to come in to read the data. Okay. So what we can do, we can go now. Now the stream is running. It is polling to look for new data that is coming in. So you also have some options to read from the beginning, but I'm just looking for the incoming streaming data. Okay, for that. So now go here, send events, go hello taxi, because this is what I'm sending. Repeat send 5. I will put 1 every 3 seconds and then publish. So when I publish, I will go here. See, the data is coming in now. It's the first, second. Now, you must be seeing, right? This is all junk data. So basically, whenever that message is read from the event hubs, it is encrypted because data is sensitive. Data always comes in the encrypted format. So you have to decrypt it. So once you put it in the bronze layer, okay, then you can go and start transforming it and then reading the data. So let's say I have this here, 5 rows that are coming in. So it has partition, offset, enqueue time, partition key we have not given, properties, system properties, and all of this. So this is the metadata. But basically all your information is in this column called body. It's a binary format. Okay, and it is encrypted data. Let's stop this. Now what we are going to do, we are going to read the stream. Okay, display, and at the same time write it to the bronze table.
Hey, Harun, sorry to interrupt. Can you
Yeah.
please show the struct type? Because whatever data we are reading was in JSON format.
Mhm.
And now what we are seeing is like body offset on the table on the bronze
Mhm.
while you are reading the data. Where
Yes.
does that transformation happening? Like how it is
So,
happening?
yeah, it is not this we have not added. We have defined this, but we have not used it yet. Okay. When you actually read anything from the event hub, by default, you get encrypted data in this format. You get a body. In the body, you will have this message. No data. What's that? How do I do the previous data? That's gone. Yeah. See here, all of this will come in as body. Encrypted format in the body. Okay. This is all there. This JSON is entirely there in that body, but it is in encrypted format. You cannot see it yet. Okay. So once you decrypt it, then you will see.
That is fine. But when we are reading it, is it Databricks is doing automatically from event hubs, or is it the standard format? How the event hubs
It is
are?
event hubs. It is event hub. Whenever you read, it will give you in the standard format that message.
Okay, that message and then offset
Yeah,
whatever
the
other
metadata you will
data
see,
is
right? So
coming.
body, it will put this everything encrypted in the body.
Okay.
Message ID, correlation ID, system properties. If you see, it will come here in the system
Okay.
properties, the correlation ID and the
Okay.
message ID is all here in this.
Okay.
And other properties, right? So it is all metadata, whatever you are sending here.
Okay.
Let's say the custom properties, and then you have where is it? This one,
Send count
partition
and
IDs and all of that, it will send. So by default, it is sending, if you have any properties, if you have any partition key, if you send by partition key, who's the publisher, what is the time that is enqueued when you publish from there, sequence number, offset. So this is all metadata that is generated by the system, by event hubs that is sending you. Okay.
Is it those properties, whatever we are setting in the event hub, is it reading everything from there then?
Yeah.
Okay.
This is one, right? So message
Yes.
ID, correlation ID is coming from here. Time is basically when you hit send, it will take system time. So that is what it will put in the enqueue time here. Okay. 0 to 25, 255, 30 seconds, first message. We put 3 seconds, right? So the next message is coming at 33 seconds. Then after 3 seconds, the next message is triggered at 36. Then after 3 seconds, 39. But because it has milliseconds, so it has actually crossed to 40. That is 779 milliseconds, right? It keeps adding that. So it has moved to 40. So something like that, but it will maintain almost 3 seconds difference when the data is enqueued. So these are all system generated sequence numbers, which partition it is putting it to by default, because we have not selected any partition. Offset is auto generated. So this is all system data. Now, once you get this is why we are having this in the bronze layer we are writing, right? So that is what we are going to write into the bronze. Once we write this, then we use our schema to do the transformations. Then we will see the data. Okay. So now let's see here. So once you write it to the bronze, what you will do, you will read the stream again from that bronze table. So first layer you're writing to bronze, and the second layer you're reading from that bronze table, transforming it and writing it to silver, right? So you're reading from yellow taxi. Here, bronze.yellow taxi, you are writing here, bronze.yellow taxi. Then you are reading from that table, bronze.yellow taxi. Now here you are doing the transformation. Okay. These two lines. With column, body string, you are creating a new column of body dot cast as string. So whatever this is this, you are converting the data type from binary to string. Okay. So when you convert that to string, then you get your everything in the JSON format. Then you are doing from JSON, this body string, you are applying the JSON schema. So this is the schema that you are defining here, right? Now you are applying that schema, this schema to that JSON string that is coming in the encrypted format, right? The first line here, you are decrypting it, casting it into string. Then that string is in JSON format. You are using your schema to convert it into a new column called body. So from there, now you can say, take each column out, body dot vendor ID, body dot rate code ID. So this will give you this data. Okay. So these are the transformations that are required. First thing, from binary to string, then you apply your JSON schema, then you extract each field from that JSON string format. Okay, so you don't need to call this body. Okay, you can call body string as, say, body. I am decrypting it. Okay, now use this decrypt thing, apply JSON schema, and then you can say this is in body JSON format. Now in body, using body JSON format, then you have to get each field. So you have to replace all of this. From the body JSON, you are getting each individual field from this. Okay, now you understand why parsing JSON file is important. We did last week. So we need to do all of that. Okay, so once you do that, you get all of these in the data frame, and then that data frame you can write to here to output mode append silver.lo taxi. And then this is same, when you go to kind of aggregations, it's just reading from the silver yellow taxi silver table and doing. But here you can see watermark, group by window. So these are all the functions that you can use when you do an aggregation. So we will discuss this when we do more detailed study of it. But let's get this until silver. Okay. So let me first, we have run this. Let me run this again. I will not run this. So I will run this so that it will get into bronze.lo taxi. And I will also run this. So that it will write to silver layer. Okay. Now we don't have anything here. It's nothing coming. So I will go and now trigger the data. Okay. I will go here, trigger this data. I'm not giving any partition here. I will put 10 records. 10 records. Interval 3000. Send. Okay, now the data will start flowing in here. So this is encrypted format. As and when the data is coming there into the bronze table, it should automatically start reading that data, decrypt it, parse the data, and then see here, you get vendor ID, each field here, passenger count. So now you got 4. The data is getting streamed as and when it is coming here. It is picking up here. It is picking up here. As and when the data is getting streamed every 3 seconds, one record is coming in. So that is getting processed by this stream into the bronze table. This is reading from bronze table and then processing it. So we got 8 rows, 2 more rows are pending. So we'll get, once we get 2 more rows, I think we'll get all 10 rows. Yeah. So 10 rows is done. So this is the data that is published. Okay. Now you can actually do the aggregations again. While it is running also, you can keep doing the aggregations. So it will keep, the data will keep changing. here. Whatever you do. So this between the start time and end time, whatever is the data, it will calculate average distance and average amount for each of these windows, right? So between that time, how many transactions, what is the total distance or average distance and average amount, it will calculate. But if you should have more data to do that processing, but this is how it gets processed. Okay. Questions? I know it's very heavy, but I think we have gone in detail, explained everything. You will have this, you will have some resources on creating Azure account, creating namespace, event hub, right? Subscription, resource group, namespace, event hub. 4 things you need to create, and then get the connection string and go to Databricks, open this notebook, create compute, install the libraries in the compute to read this, and then process and run. Go to event hubs, publish events, and this will start processing. So run this. While this is running, you can go and stream the events from there. That's the summary. Questions?
Arun, so we did not create any consumers, right? So
This is your
in
consumer.
our code also, this is a consumer. So it is
Yeah,
pulling the
this is
data
what
from
is
all
reading,
data.
right?
Okay, okay. It is.
Yeah, whatever is reading
But
from event hubs is your consumer. You are reading this topic, right? You are reading this event hub.
okay,
Starbucks
so we
demos.
put default consumer on that side, right? I think when we create event hubs, option as a default
Yeah,
consumer.
so
So what does it
in the
mean?
Databricks,
Mhm.
using the Databricks, we are creating the consumer here, reading this event hubs with this configuration. So this is the default consumer. When you are reading from event hubs, you are a consumer.
Okay, default.
If you are writing to an event hub, you are a producer.
Yeah,
Okay,
can
if
you
you
share the
create any consumer, okay.
Sorry, yeah, Kanavi, go ahead. Let share.
So here the data is consuming from both partitions, right? 0 and 1.
Yes,
So
yes.
no
You can see here
specification here,
0,
right?
1, 0,
Okay.
1, 0.
Yeah.
Yeah. It's a round robin. It will go to one
Oh, okay.
partition, read, it will go to another partition, read, because you have only one consumer. If you create a consumer
Okay.
group with 2 consumers, then each consumer will read from one partition. Then you will also have consumer IDs and all of that somewhere. But let's not go that deep right now.
Okay.
But as long as we understand the concept, that's fine. Okay.
Okay.
Yeah. Anshu, you had a question?
Just wanted to see the configuration one more time.
Which configuration?
Yeah, ehconf.
This one.
Yeah, at the down this dictionary ehconf.
Yeah, this is the standard.
So you mentioned that we can define the consumer. Okay, so if I want to create a separate consumer, I will have there can be a different configuration, right? To read it from.
No,
So
all
in the
consumers
public,
will use the same because you are reading from this topic. If you create another event hub, then this will change.
then yeah. So this
But namespace will remain same.
yeah, namespace will remain same, but the topic name will be changed.
Yeah, this will
Okay.
change.
Yeah, yeah.
Your
Okay.
event hub name will change.
Okay.
But whatever namespace you create, if you go and take that connect string, it will give you this connection string.
Okay.
Okay, and the same event hub name you will put here.
So this is one consumer, and I can read from two different event hubs as well, right?
You have to do a different connection with a different event hub name.
Yeah.
One consumer can read from only one topic.
Okay.
It can read from multiple partitions within the topic.
Oh, okay. Okay.
But same consumer cannot read from multiple topics.
But when we were discussing, we discussed that there is a phone number. So one consumer. So we have different. We had 3 or 4 different event hubs. One was for customer information. One was for address. One was for just for email. So
Create another
one.
connection string with another entity path, the second topic.
Okay.
And then you create another stream to read from that.
Oh, okay. Okay. So that will be kind of completely like
you can have another notebook.
Okay.
Change the topic, and you can run both the notebooks in parallel, and you can keep publishing events to both the topics. So everything will be running. Whichever gets the event, it will read and process.
Okay. That is what we'll call.
You can duplicate this tab, open another notebook, change the topic name, and start it. Run that, run this, both. It will run. Both will be running. So whichever topic you send to, it will go to that. Okay. And maybe you can have 2 different tables. So you send one event, that particular consumer will read from that topic, and that will go to that table. If you publish to another event to another event hub, so the second notebook, which is looking for that topic, will pick up that and then write to that table.
Okay.
Okay. So you have to always remember rules. One consumer can read from multiple
partitions.
Partitions.
One consumer can read from multiple partitions. Okay. But one consumer can read from multiple partitions, but 2 consumers cannot read from same partition, from the same consumer group. Remember, I was saying if there are 4 partitions, and in the consumer group you have created 8 consumers. It doesn't mean that 2 consumers will go and fetch from one partition. No, one consumer can read from one partition. Only one consumer can read. Okay, it's other way around. One consumer can read from 2 partitions, but 2 consumers cannot read from same partition. I know it's a little confusing, but you have to remember that golden rule, because it will have a conflict. Okay, that partition cannot know which consumer is reading what. So there might be duplicates. Both the consumers will be reading from same partition, so they might be reading same message, right? So it cannot maintain the state, the watermark. Okay, so if it is for each consumer group, it will say, hey, this is the consumer, it has read from up to this point. Next time when it comes in, it will give the next message. Okay, so that is why that parallelism rule is you can have as many consumers as partitions in the consumer group. If you have more consumers, they will be just idle, because one consumer can only read from one partition. It cannot read from 2 partitions. 2 consumers cannot read from one partition. Am I saying it right? No.
Yeah. So, but at the same time, so for one consumer,
can read from multiple partitions. Yes.
Multiple topics also. No. Here in this case.
No.
It's a default consumer. It's a default consumer. I can create another string in the same session, another string for the another partition. I'm sorry, another topic, which has only this data like.
Yeah. See, the moment you create another stream, it is a different consumer, different consumer group. Okay. The moment you create Spark.read stream, it's a new consumer group and new consumers.
Okay, but okay, got it. So it will be in the same session I can create, right? Multiple consumers, or it's a different session
Yeah,
I
you
have to
can
create.
create multiple consumers. So you can go to
Consumers,
another
right?
cell
Uh-huh.
and then create another read stream and then give different configuration. So that will be another consumer group.
Another consumer. Okay. Okay. Mhm.
You can give different topic. So this will change, right? So instead of ehconf, you can say ehconf1, ehconf2, create two different configurations. But connection string also has to change, right? So in the entity path, you have to change this. So you can just have another copy of this with the different names and then create different consumer to read. Okay, first don't get confused, don't get overwhelmed. Just stick to one consumer, one partition. Just get it running, everything, then go to the next level. Don't try all things at once. You'll get confused. First, get this running on your setup. You will understand at least streaming, reading, storing, bronze, transformation, silver. Then you can take it to the next level. How you can publish to multiple topics, how you can read from multiple consumers. That is the next step. So first let this digest, get it running. Okay.
Yeah. Okay. Okay.
All right. Ramya, Rahul, Anirudh, Narsimha, not hearing anything
Yes,
from
sir.
you guys. Either you have
Yeah.
understood everything or you understood nothing.
Yes, I'm able to understand.
Okay.
Same here, Harun.
Okay. I need pretty much a bit more time to analyze all these.
Digest
I need to
a lot of
review these
information.
video again, and I have to get
Yeah.
back. Yeah,
Sure.
definitely.
Yeah, take your
I have a
time,
lot
but
of questions.
as I said, yeah, spend more time, digest, explore, work on it, and then we'll come back. Okay.
Yeah, sure.
All right. That's all for today. I will schedule one more session during the week. We will briefly touch on this. I think we are almost done with this event hubs, and then we will move on to Kafka. Okay. Because we are on the event model. So once we go on to Kafka, we can wrap up all the streaming and event models. Okay. Then we will move on to Snowflake and probably touch on the Airflow after that. Okay. All right. Thank you so much. Appreciate your joining. Again, we'll meet again soon this week. Take care. Have a good day. Okay.
Sure. Thank
Any
you.
questions?
Thank you. Good night.
Sure.
Yeah. Thank you. Take care.
Good night.
Yeah, thank you.